Those of you who have joined, if you can hear me, please put in your names and roll numbers in the chat box.
Okay,
Ma'am,
ma'am.
one new student have joined, but she has
One,
not yet received her roll number.
who is that?
Ma'am, Apabhrita Sengupta.
Okay, you put in your name at least so that I can make a note of your name. When you
Okay,
get
ma'am.
your roll number, just let me know.
Okay, ma'am.
Okay. 1 second. I wait for another 2 minutes. 21 of you are already there, no? So shall I begin so that we can
Yes,
finish
ma'am.
quickly? Okay,
Okay, ma'am.
1 minute. Oh, okay. As far as I remember, in the last class, okay, somebody is joining. The last class, we talked about the concept of safety and risk. We try to differentiate between what is safety and risk, and we concluded that safety and risk are two sides of a coin, and the two terms are often used synonymously. All right. So the understanding that we get is that when the the safety factor is less, it maximizes the risk factor, and vice versa. So vice versa meaning if the safety is more, the risk is less. And as engineers, as creators of products, it is expected that all engineers, um, or anybody in any profession, a professional is expected to maximize safety, all right, and minimize the eventuality of any kind of risk in the products that are being used by their customers, all right. So if an engineer fails to work up on maximizing safety, all right, and leaving more room or space for risk, all right, then he is being unethical in his dealings, because his job as a professional, or his role as a true professional, as an engineer, is to give maximum benefit to society, all right, to his customers, to his stakeholders, all right. And if he does not do that, he is failing in his job or in his role as a true professional. Now, there could be reasons why an engineer could probably, or a profession could be probably trying to maximize risk and minimize safety. It could probably be because he wants to maximize his own business gains, but this is what is unethical. All right, you're not supposed to be thinking about, you're not, we talked about egoism, one of the theories of ethics. All right, egoism cannot take the, what should I say, primary role here. So what you're supposed to think about is maximizing uh, the chances of safety and not chances, maximizing safety and minimizing the chances of risk. All right. Now the thing is, in any product that we use, any true professional will want to actually maximize the safety of the product. All right. A little bit of risk can be tagging along with that bit of safety. If there is 90% safety, then there is 10% risk involved. Now this 10% risk is not a great thing if the product is used appropriately. All right. The engineer who creates a product will try to minimize the risk factor as much as possible. And how is that done? Through repeated testing procedures. All right. The creations, the projects that engineers take up are repeatedly, or they are sent for repeated testing, all right, and analysis of whether the product is safe to be used. Now if there is any little bit of of risk involved, it is not a big factor, all right, and it cannot actually cause harm to anybody if the product is used as it should be used. Is that clear? Now, when you misuse a product, then there is a chance that even if there is 1% of risk involved in the usage of any product, that 1% of risk can cause big damage or harm or loss of property or life. And the engineers cannot be blamed for that. But as an engineer, it is expected that all of you will try to maximize the benefit and the safety of the product and minimize the pain or the risk factor involved in using a product. All right. And then we talked about 6 types of risks. All right. I'm not going to go into that again because we'll be missing out a lot if I, for the newcomers, if I start again. We will move on to another concept called accidents. Now, when do accidents happen? Accidents why are we talking about accidents? Accidents can happen when somebody does not use a product according to the instructions that are given to them, or the creator of the product has not taken enough care to assure that loss of life or any kind of injury or pain can be caused to the user. He has not paid enough attention to that. And that is why the safety factor has lessened and the percentage of risk has increased. Now, when the risk increases, accidents can happen. Now, accidents can happen because you are not doing something deliberately. It happens. All right. Now, it is up to the creator of a product to see that how they can minimize the occurrence of any accident. All right. For that, as I said, we do something called a risk analysis, where the R&D, the research and development wing of any organization, will keep conducting repeated tests, all right, trials and errors to see what can cause the risk factor to increase and then work on it to minimize it. See that even if somebody misuses it, the damage is as little as possible. All right. So accidents can happen, and accidents can happen either because the risk factor is high, somebody has overlooked the risk factor, all right, has not paid enough attention to maximizing the safety of the product, all right. Or it can happen, accidents can happen when the user of a product consciously or unconsciously misuses a product. Is that clear? For example, as I said, I can be ironing clothes and using an iron box in which there are raw wires, all right, which can be dangerous. Now, the person who has created this iron box definitely has not said that it is safe to use an iron box with the raw wires, poking out of the insulation, coming out of the insulation. So, in spite of that, if you as a user want to use it, you are taking a risk. All right. Now, to minimize that risk, what is suggested in the user, manual itself, it will be given that if something like this happens when the wires have come out loose or they are open, immediately get it insulated. Now, when you keep using a product like this with wires open, you might be used to ironing your clothes with that kind of a risk. All right. And you know that if I put my hand there, I could be electrocuted, or I can get an electric shock. Now, if that iron box is being used by somebody else, he may not be used to the fact that, this thing is happening and by mistake put his hand there. One day, maybe you can also put your hand on it with the, switch on. In that case, accidents can happen. So, what can we do to minimize accidents? And what are accidents actually? How do they occur? That is what we are going to see in our uh, slides today. Okay, I will share my slide with you. Just let me know if it is visible. It's not visible. Okay, is my slide visible to you?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So the next two slides are just run on of the topics that we did in the previous class. I rushed through a little bit. So these are just summary of the previous topics that we did. We started talking about safety. We started talking about risk, and then we talked about 6 kinds of risks. And today we'll try to conclude that topic before we move on to what is risk. What is risk benefit analysis, and what we mean by accident. So that will be the main focus of our discussion today. So safety and the engineer. So we talked about risks. Now what about safety? All right, all these are interrelated, and I said safety and risk are two sides of the coin, and that is why I also said that the two terms go simultaneously. All right, sometimes people use safety along with risk, meaning the same. If there is no if there is safety, then there is no risk. So the two terms always go parallel. Okay. Now, safety is an essential aspect of our duty as engineers. How can we be sure that our designs are safe? Now, in the last class, I don't know if you remember, I said that the concept of safety varies from person to person, all right, depending on his age, depending on his expertise, his experience, his wisdom, all right. Like I said, an electrician can probably will if you call an electrician for any kind of work, and he works, he checks, he uses a valve and live wires, he puts it into the what you call the plug point directly, and checks for whether the line is there or not. Sometimes you will find them standing bare feet. If we were to do it, we would put our rubber footwear, or use a stand on a piece of wood or something before we do something like that. But an experienced electrician usually does not do that, because he has experience. He knows how far he can go without wearing rubber footwear or standing on wood. All right. And that is why that is a difference between him and us. For him, safety is at another level. For us, safety and the same thing is at another level. All right. So that is about experience. His wisdom tells him that up to this level I can stand bare feet and handle raw wires, but after this I cannot do it. Okay. So many experienced electricians have lost lives because they have what should I say, uh, either they've lost control, or they've not been able to bring about that balance between the safety and risk factor, when any safe thing can become risky. All right, that's why many of them have lost their lives. Now, how can we be sure that as engineers, the products that we have created, the designs that we have made are safe? Designs of products that we have made, starting with design, and the design of the machine or the product that we have made are safe. I could simply say, that a carpenter designed a table, all right, and it is such that that table has 4 corners in a very small space, and the 4 corners, the design is such that it's very risky. All right. So how can you assure that it's safety? I remember in one of my relatives' place, they had a kind of a stand or a rack. I don't know what, maybe a stand, where they had all their religious things, the god and goddesses, all those things, and the diyas and all that put up. And it was to the left of their drawing room door, and just below that rack they had a sofa. So it often happened that whenever people sat there and were not aware, see, this is what happens, accidents can happen that time. we are regular, users of that room and that sofa there. And so that's why when we get up, we are very careful to bend our heads and get up. But people who are not aware of it, every time they stood up, they hit their heads on that, the rack there. And very often we found that my mother-in-law she lost her eyesight and she couldn't see very well. But she would light a candle every evening on that stand there. And because she was not able to see once, she didn't place the candle properly. She thought she had put it and she left a burning candle. And very soon we found that the candle had fallen over on the sofa and had caught fire. So this is about safety and risk. Sometimes you're very used to certain things and you think that it is safe. But when the risk factor will rise and an accident can happen, nobody can tell. So how can you be sure that whatever you design is actually safe for use? As engineers, what should you do? What should you keep in mind? Now, there are 4 criteria that must be met to help that the design is safe, to ensure that the design is safe. What are the 4? There could be more, but these are 4 that I have listed. The minimum requirement is that a design must comply with the applicable laws, which means that you could design a washing machine, you can design a geyser, you can design a computer, you can design a mobile phone, you can design, what should I say, a micro oven, any gadget. You can design anything, but the product that you design must comply or follow certain norms that have been laid out. You have to go by those laws. Just by designing something, it doesn't mean that your product is ready to be used. So your product must be designed according to certain laws that have been laid down by your field of study. Your specialized training must help the code of ethics. The code that is there for designing a product must be followed. All right, whether you are a civil engineer or an electrical or a what is that, electronics engineer, electronics and communication engineer, whatever it is, the gadget or the product that you design must fulfill the laws that are already laid out for the designing of a product, because that product is going to be used by somebody. It's not going to decorate the racks in any showroom. It's not just for that. The second thing is an acceptable design must meet the standard of accepted engineering practice. This is an extension of the previous one. The first one just says the design, okay? In general, the design. The second point says that the acceptable, after the design has been accepted, one further step forward is that the product that you have created must meet the accepted standards of engineering, the rules of engineering practice, what you have learned. All right. See, whenever if you I'll move out of the engineering practice and tell you, we studied in a convent school, and we had these, this handwork classes and all that. So the nuns used to teach us, the nuns specifically used to teach us embroidery. All right. And we were marked on that. And they repeatedly used to tell us that when you have finished with a particular design embroidery on a piece of cloth, all right, the front and the back side of the cloth must be same. Nobody must be able to differentiate between the right side and the wrong side. The side, the back side where you've put knots. That neat and clean your work should be. Nobody should not be, if we are able to see knots or we are able to identify that this is the back side of the work that you have done, we will reduce marks. So that is that was a norm of embroidery. All right, the accepted practice standards which we had to comply with. All right, if you can say applicable laws, the laws that applied there were that your work had to be very neat. All right, nobody should be able to differentiate between the top and the bottom side of your of your embroidery. All right, your piece of work. So this was something, in those days the Christian nuns were very adept or well trained at all these things, and they trained us on this. So we had to be they would always keep a watch out for this, and they would make sure that we followed these norms, we complied with these rules that they said. All right. So that was about not only safe designing, but also perfect designing and perfect work. All right. It must be acceptable. Is that clear? So in engineering practice also, you will have certain perfections that have to be met, and that you must keep in mind. Okay. Alternate designs that are potentially safer must be explored. Now, if you have designed something and the R&D says that no, there is a potential danger in using this kind of a product because of the design, and you must change it, then you must be open to alternate designs that are safer than the previous ones, and you have to work on that. You have to research on what can be better than what you did, because there was probably some risk factor involved in the previous design that you made. The fourth point criteria is that to ensure safety, what engineers can do, the fourth point is the engineer must attempt to foresee potential misuses of the product by the consumer. See, this is what I said before. The engineer must keep in mind that the, the product that he is creating may be misused by the user or the consumer. All right. He must keep that in mind and accordingly design the product to avoid these problems that could be arising because of misuse. Maybe he cannot entirely negate the risk factor, but he must try to minimize as much as possible. Harm that can be caused to the consumer must be minimized as far as possible when the designing of a product is taking place. So this requires a fair amount of creativity and research. Is that clear? So as engineers, it is not enough for you to pass your theory exams, but it is also very important that you use your creativity, your research to make your product feasible, reliable, and original. Is that clear? It's very difficult to bring about a very good balance of all these three things. Okay. The next topic that we'll be discussing is designing for safety. So, how can we assure that engineers can, whatever they design is being designed for safety? How should safety be incorporated into the engineering design process? And when I'm talking about engineering, I'm talking about engineering in general. Okay, I'm not talking only about civil engineering or electrical or mechanical or electronics and communication or computer engineering in general, because all these streams or specializations in engineering create products. All right. So, how should safety be incorporated into the engineering design process? First, you have to define the problem. I have designed something, all right. The research department has looked into it, they've analyzed everything, they're seeing the pros and cons, and they may have identified a problem. So you have to the research department has to define the problem, all right. And what is defining the problem? What does it involve? It involves determining the needs and requirements, all right, of the product that is going to be used. What is the need? What is the requirement of that product? And often involves determining the constraints, the problems of using that. For example, I want to use a geyser. All right. What is the first step for me to why is the first step is to find out what is the need or requirement for me to use a geyser. Obviously, because I needed to heat water. That is a need, that is a requirement, primary requirement. Now, I have probably designed a water heater, all right, a geyser. Now, what are the problems that are showing in this new or this new thing that I have created? There are so many geysers in the market, and I have created something new. All right, how is it different from the others? Is it fulfilling the primary need? And in fulfilling the primary need, what kind of problems is my design or product encountering? For example, let's say um, this washing machine is going to be used in a hotel. Okay. So the first thing that I'm going to realize or understand is that the product that I'm creating, the geyser that I'm going to create, must first help me heat water. So how am I going to do that? All right. Now, what will be the size of my geyser? That will depend on where it is going to be placed and who is going to use it. So the need and requirement has to be identified. Who is going to use it? How many people are going to use it? Is it going to be a large number of people who are going to use it? Then should I have an electrical geyser like this, or can I offer something which can work on solar power? Am I going to design an instant geyser water heater, or is it going to be a big store well? And how big is it going to be? Now if your size is very big because you want to heat a lot of water at the same time, you'll have to keep in mind that the size factor can sometimes become a constraint. If it's too big and too much of water, it might fall. It might take up too much space in a washroom in a hotel, or even in a house. Now people live in flats, all right, the bathrooms are very small, washrooms are quite small. So just because I have the ability to buy a big washing machine, or there are too many people in my house and I can't have a geyser in every bathroom, or I just have one washroom, and if it's a small one, it takes long time for the water to heat. So I'll make a big one where many people, large families, can use them. Now, will this thing fit into the place where it is going to be used? Will it actually fulfill the need of the user, the size? All right. Also, you have to keep in mind the electricity consumption. So you have to define problems that can be encountered and problems or constraints that could be encountered, keeping in mind the need and requirement of the product that you have designed. All right. The second way you can ensure safety of the product that you're creating is by generating several solutions, which means you come out with multiple alternate designs, okay, that can suit the various types of consumers or users. You can create a geyser that can be used for small bathrooms, that can be used for small washroom, small families. All right. You can design an instant geyser which can be used by everybody. It's universal, irrespective of the fact that it uses a large bathroom space or a small washroom space. All right. Now, also you can design a washing machine. A geyser, keeping in mind that this geyser that I've designed can be used in a washroom. Also, can be used in kitchens, for example, in hospitals, can be used in hotels, can be used at home also. You will have to customize the design, all right, so that it can be used in different places. So you have to keep those options free without compromising on the actual need and the safety of the product that you are creating. Now, how can you do this? By analyzing each solution to determine the pros and cons of and determining the pros and cons of the product that you've created. And what does this mean? It means determining the consequences or results of each design solution, the outcome of each design solution, and determining whether it solves the problem. All right, whether this design can be used in the three places that I mentioned, maybe in a kitchen, in a hotel, in a hotel washroom, in a residential home washroom of a residential house, in a hospital. All right. Sometimes you might need to heat water. Let's say you design some kind of a water heater which can be used kitchens of residential homes also, and the water that is being heated is safe enough to be used for drinking. You want to make tea or coffee in a school, let's say. All right, you need some hot water that can be used for by maybe the management or the school students and teachers to make some kind of beverages in the staff room. So is your design universal and well customized to be used in all these places? You have to analyze to find out what are the advantages and disadvantages of the product that you have created. All right, so that is what we mean. Now, after the analysis is done, you have to test whether what you have analyzed and the results that you have got are okay. You have to test the solutions. All right, the results that you obtained after the research, after the analysis, have to be put into practice to test if your findings are right or wrong. Depending on whether your findings are right or wrong, you can move ahead to the next step with your product. Now, after you've done you have tested all the solutions that you have received, the results that you have got, you will try to select the best solution in terms of money, in terms of space, in terms of fulfilling the needs and requirements of the consumer, in terms of the space where it is going to occupy. All right, all these things you will have to keep in mind. The cost involved, all these things. So you will select the best solution, and that is how you will start fine tuning the product that you are going to implement in the market, which you're going to give final shape and then implement for use or put it for use to your customers. So these are 4 steps that you have to keep in mind to ensure safety during the engineering design process. Now, in the first step where you define the problem, it is necessary or appropriate to include issues of safety in the product definition and specification, which means that, as I said, you have to specify what is the product, why you are creating it. All right, try to answer as many of the 5 WH questions: what, where, why, all right, when it is to be used. All these things, the product usage must be defined and specified. All right, so these have to be stated. Now, when you move on to the next step, from step 2 to step 5, engineers typically consider issues of how well the solution meets the specifications. You come out with a lot of solutions. When the solutions or the outcome has come after your analysis and research, all right, whatever solutions, your final solution has come, you have to place it against the first one, whether your solution actually meets the needs of the product that has been created, whether the geyser that you have designed actually meets the need, it fulfills the condition of being created. Is that clear? Then, as I said, you will have to think about how easy it will be to make it now. All right, now that you've got all the solutions, you have all the pros and cons, and you have the best product in hand now, you will have to see how feasible it will be, how you will build it. All right, how feasible, how costly it will be. All these things you will have to check out. Now, safety is especially important in step 5, where the designer attempts to assess all the trade-off required to obtain a successful final design. All right, that is what I said. Now, when your final product is got after all these 5 steps have been implemented, there should be no room for anybody to say that, this product is not safe for use. That should not happen. So these 5 steps should be followed properly, to the book, so that there is no room for any risk factor in the usage of the product that you have designed. Is that clear? Now, all these things come under something called the risk-benefit analysis, which I talked to you in the previous class. What is risk-benefit analysis? It is a method which engineers sometimes use to analyze risks and to determine whether a project should be taken forward, whether you should proceed with the project. So after these, the 5 steps that you follow in the previous slide that we saw, to minimize risks and maximize safety, is called risk-benefit analysis. How much risk is there and how much safety is there? If there is too much of safety, then it is beneficial. So that's why it's called the risk-benefit analysis, which has to be done for any product that is created. Here, the risks and benefits are given paramount importance, utmost importance, and the most favorable ratio between the risks and benefits are sought. That is what I said in the 5th point, isn't it? You will implement a thing only after you have tested out the solutions, and you will finally zero down on the best solution. So you do the risk benefit analysis, and then you will zero down on the best solution. That is where, when will you zero down on the best possible solution? When the favorable ratio between the risks and benefits are understood, when they have been clearly stated. All right. In doing so, one must consider who takes the risks and who reaps the benefits. All right. Now, you create a geyser or a washing machine or whatever it is, and you concentrate on giving maximum benefit to the user. All right. But that doesn't mean that the creator or the producer of that product runs into loss. So that is what this bullet point means. One must consider who takes the risks. Will the business partner, the business take the risk? Will your company take the risk? Will the creator of the product take the risk entirely, and all the benefits be taken entirely by the consumer? This is a question that you have to keep in mind, because if you're going to take all the risks, then your business might run into loss. So there has to be a balance. I will do maximum benefit for the user and also try to keep some benefit for myself. And it should not be the other way around, that I will take the maximum benefit and compromise on the benefit of the safety for the consumer. Then your company is gone for a sixer. All of you will lose your jobs and end up being behind bars. All right. So it is important to be sure that those who are taking the risks are also those who are benefiting, which means that as an engineer, who represents a particular company, I must make sure that the team, the the research team, the production team benefits from this, and indirectly the organization also, the company also benefits because of these, the production and the research team. It should not be a one way traffic. Okay, both the consumer and the producer, both must benefit. Nobody must run into loss. The only ethical way to implement risk benefit analysis is for the engineer to ensure, to the greatest extent possible, that the risks as well as the benefits of his design are shared equally in society. And the society means the society in which he works, his company, and the society in which consumers exist, the people who will use his product. So there has to be a balance between the two. The risk and the benefit should be equally shared between both the societies or both the parties, and it should be a win-win or loss-loss situation for both. It shouldn't be weighing down on any one of the parties. Is that clear? So that is what risk benefit analysis is all about. Now, shall I give you a 5-minute break and then start off with the topic of accidents?
Okay, ma'am.
Okay, we take
Okay,
a
ma'am. Okay, ma'am.
5 minute. It's about 3:10. You want to join at 3:15 or at 3:20?
And 320.
Ma'am, start. Okay, ma'am.
Okay, 3:20. I will
Okay,
start
ma'am.
with accidents, and it's quite interesting. We'll try to. I think we'll be able to finish by 4 o'clock.
Okay, ma'am. Thank you.
Okay, so
Okay, ma'am.
okay, take a break, and we'll come back at 3:20. Okay.
Okay, ma'am.
Can we begin?
Ma'am, few students have not yet joined.
Okay, we'll wait. Meanwhile, I'll make a note of the attendance. There's a join late. Mishra 311, 101, 416, 419. Okay, I saw a few of you have sent your assignments. The others, can you start putting your assignments because I need to check your, I need to put down your marks and send them. So those of you who haven't yet, please mail me your assignments to the email ID where you submitted your answer papers. Is that clear? Submit it there, not to my personal email ID. Some of you are sending it to my personal email ID. I might miss it out there. So there's one exclusively for your assignments, your answer papers. So please mail your assignments there. Why has Shovik put in his name twice? Okay, shall we begin? Otherwise,
Yes,
we will
ma'am.
get late, we will not
Yes,
be
ma'am.
able to finish. All right, so we'll start. So we will move on to the, as I said, we wanted to talk about accidents. We talked about risk benefit analysis. We will talk now about accidents. And just like we talked about what risk is and the different types of risks, we'll talk about accidents and the different types. Okay? Okay. Now, before we begin, let's go into the types. Let's find out what we mean by accidents. So, an accident is like a risk, it is unplanned, unintended, and unexpected event. All right? We don't plan an accident, it just happens. The term implies that such an event may have an unforeseen or unintended exposure to risk. Very clear. I mean, an accident happens because we are exposed to some kind of risk which is unexpected, which we may not have predicted. Unforeseen meaning have a prediction that it is going to happen, and it is not intended. All right, if somebody deliberately does something to you that is not an accident. An accident happens just like that. You can never plan it. Okay, and therefore it may involve a risk that has not been identified, or to a risk that has been identified but not adequately controlled. Now, this is it. Now, who will take responsibility of this? Who is at fault if an accident happens? Does it happen because somebody has identified the risk, and has gone ahead with saying that taken it head on and gone forward, or because a risk that has not been identified at all? Now, a risk that has been identified but not adequately controlled, or measures have been taken to minimize it. All right, accidents can happen either way because of a risk that has been identified. All right, like I said, for the iron box, when I'm ironing clothes, I identify the risk that there are live wires, there are open wires on which if I put my hand, I might get an electric shock. All right, that is a risk. I have identified the risk, and yet I continue to use the product. Or accidents can happen if a risk has not been identified. It has been identified, but I have not taken adequate steps to control it. For example, the same thing about the iron box. Okay, I have identified that is what I was saying. I got a little confused. Wait, the first one says it may involve a risk that has not been identified. Okay, let's say that. Okay, let's take an iron box, or let's say a geyser. I've been using this example all the time. I'm talking about geyser. All right, and there has been some kind of water seepage. All right, where the wires are passing or at the plug point. Okay, and there is a chance of electrocution. Is that clear? So what happens is, when I cannot see from outside, that water has seeped in somewhere in the walls and has come in contact with the wires, all right, which are connected to the geyser. Okay, so there is a risk involved here in using the geyser, or when I touch the tap, I might get electrocuted, or if I touch the water, I can get electrocuted. But this accident can happen unknowingly because I did not know that there was a risk that was there, and it could not be seen, it could not be identified. If I had identified it, then I would not have probably touched or used the geyser that day or at that point of time. So an accident can happen when you know that there is a fault, or when you do not know when there is a fault. So in the first example, I do not know that there is a fault in the wire, and water is having seeped in, and the lines getting what should I say, coming in contact with water. So I do not know about it, and I touch the tap and I get electrocuted. All right. Now, that is when I do not know about the risk that is hidden. Sometimes the risk is open. I know about it, but I do not take action to control it. It can be with a geyser or with an iron box that I've been going on telling, that our live wires in the iron box are out. Okay. And I know that there is a risk. I can see it. I have identified the risk, but I don't bother to insulate it properly. So I am exposing myself to some kind of risk which might end up in a fatal accident. Okay, so in the first case, I cannot identify it, and an accident can happen. In the second case, and in the first case, when you cannot identify it, it's very unfortunate if somebody, if it causes loss of life or a major kind of harm or injury to the user of the product. In the second case, it is being careless. I have identified the problem, but maybe I'm lazy or I'm indifferent, and I do not bother to take action to control or find a remedy to minimize the risk and accident and the happening of an accident. I do not do it. Is that clear? So accidents can happen either way. Accidents can happen. Another example I can give you is you ride a bike, all right, and you do not wear a helmet, all right. So when you do not wear a helmet while riding, you know that it can cause damage, or you're taking a risk, all right, which is very dangerous, and an accident can happen, and you're not taking appropriate or adequate action by not wearing the helmet. You know it can cause an accident, but still you won't wear the helmet. That is one. Accidents may occur the other way around also. When you know that accidents can happen if you don't wear a helmet, you take action and you wear the helmet. And yet there is an accident. That is unprecedented. You never thought that it can happen before. All right, you've taken necessary precaution, but maybe somebody else has been careless, all right, and you are the victim of someone else's carelessness. So accidents can happen either way, when the risk has been identified or not identified. Is that clear? Accidents seldom have one single cause. Very true. It's not just one single cause. The accident can happen because uh, the cause starts somewhere and keeps adding up, and either they're ignoring all the causes or the causes are hidden. When it's unexpected, when you can't identify it, it's because it's hidden. Maybe somewhere inside things are happening, but you're not aware of it. It is not showing. So you can't identify it. If you had identified it, you would have probably taken action to control it. And sometimes even otherwise, there are various, like riding a bike. You know what, I mean, an accident cannot happen just because you're not wearing a helmet. It's probably because you're not wearing a helmet. It is also because you don't follow traffic rules. It is also because you are talking on a mobile phone while you're driving, all right, or you're listening to music, or you are racing. All these things can form a chain, and one day an accident can happen. And here you're doing everything knowingly. You have identified the risks and yet you're doing it. And that is why accidents can happen. So both, it's not only because of one reason. Accidents can happen when small risks keep piling up and become one big thing one day. All right. So in almost all cases, a number of factors will have contributed to an accident occurring. That's what I said. A number of factors, hidden or otherwise, will contribute to an accident, occurrence of an accident. Some factors that cause accidents in engineering. Let's have a look at them. Human error or personal error. Personnel here is not, look at the spelling. Personal meaning person, not the individual. Personal meaning some person who is involved in a particular thing. All right. So it can be human error, and the person is a human being. So it can happen because of human error or personal error. Here, personal meaning, what did I say? Not a personal meaning, some kind of a person, but it's not you. All right, it can be any person. That's what we mean, a personal error. Because some person has made some kind of an error, not you, the individual, but some person who is a human being also. Accidents in engineering can happen because of manufacturing defects leading to malfunction or failure of structures, engines, and other systems. With regard to this, you will find a number of examples on the internet, all right? And I will give you an assignment where you will write on accidents occurring in engineering because of manufacturing defects. You can make a note of the question. Cite instances of manufacturing defects in engineering that have led to accidents. Will you take down the question? Cite instances where manufacturing defects caused what is that? Accidents in engineering. You will find various examples on the net. All right. Pick up at least 3 of them. Is that clear? Pick up at least 3 of them. It could even overlap with human error, because manufacturing defect is not just a machine doing it. It involves some kind of human error also, probably maybe the involvement of a human being also, of a person who was involved in the engineering process. So it can overlap on that also. Okay. Deficient and improper maintenance. All right. Large machinery or machines which are not routinely what should I say, serviced, okay, can cause accidents. You can pick up examples of that also. All right. You can pick up actually any site instances, meaning which relate to any of these bullet points, 5 bullet points, arising out of human error or manufacturing defects or deficiency in improper maintenance. All these things, any of these causes can be used, can be cited. You can cite examples relating to any of these bullet points to show how accidents can happen in engineering because of any of these. Hazardous environment involving weather, all right, heavy rains and electrical equipment, all right, or extreme weather conditions that have caused accidents in engineering. You can pick up any example. Try to pick up at least 2 for as many of these last bullet points that I have put up. Improper training, not giving proper training to the user of that machine, all right, resulting in an accident. Big machines that are not where the user, all right, in big factories you can have people who handle big machinery. If they are not properly trained to use them, all right, then accidents can occur. So you can use any of these 5 bullet points and come out with at least 3 or 4 instances relating to these, all right, 3 or 4 instances relating to any of these points that have caused accidents in engineering. So pick up any of these factors, all right, and cite 3 or 4 examples which are of these factors that have caused accidents in engineering. Did you get my question? Did you understand what I'm saying?
Yes,
Ma'am,
ma'am.
could you repeat the question once more?
Okay.
I just need to check it.
Okay. I opened up the question a little more. Initially, I limited it to manufacturing defect. I'll open it up a little more. I will put the question this way. Refer to, or sorry, cite instances of factors that caused accidents in engineering. Cite instances of factors which caused accidents in engineering. And the factors, I have put them down here. Clear now? Cite factors that caused accidents in engineering.
Yes, ma'am.
Okay. You can refer to the net and come out. And this, you will put the date. You will put today's date and put your names, your roll numbers, your stream. And it can be handwritten, it can be typed. You can put it in PDF or whatever you want. And you will mail it to me in the same email and write assignment 2. Right, assignment 2, this one on accidents. Put the topic as accidents or factors that cause accidents in engineering. Put the question and write your name, or you put your roll number first, dash your name in the file. Clear?
Yes, ma'am.
Okay, fine. Any questions here, or can I move on? Are any of you aware by any chance that you of any kind of accidents that have risen in any place you personally have seen or have heard? You can share the instance with your classmates and even with me here. Are you aware of any kind of accident that has happened in engineering because of any of these factors or any other factor? I may have missed out. So any other factor, is anybody aware of anything? Have you ever heard of something like this? an accident that arose in a factory or anywhere because of engineering. See, one common thing is this. I don't know if if it's true. These Chinese, what should I say, cell phones, mobile phones. Okay, I'm told that maybe they're not branded, that's why I don't know, but they tend to heat up, the battery swells up and it has burst, causing loss of life, accidents and loss of life. Is that true? I have seen them in Facebook and WhatsApp, all these things, videos keep circulating. Do you agree with such things?
No, ma'am, it's partial, but it's not completely true.
Okay, so see, it if it is true, it could be because of uh, deficient and improper maintenance of the gadget by the user. All right, or what should I say, improper usage. Okay, I don't know if it's because of manufacturing defect and malfunctioning, which has caused these batteries to heat up and burst. It could be human error also. Human error meaning carelessness on the part of the user or on the person who has designed it, who has overlooked the fact that a phone can be used for a long period of time and the battery in this particular model can heat up and burst. Um, I don't know if I talked to your batch about, I think it was this Volkswagen car, that also it was called back into the market because of some because of the what is that, the pollution, what is that, the it was causing pollution, and one part, whichever, from where the gas comes out, it was causing environmental pollution. All right, so things like that can happen. It can be an error in designing or manufacturing defect, or because of improper designing and lack of research. And see, that is why I said factors can involve deficiency in research and in the research and, what should I say, testing of a product. You can put up that point also. Insufficient research and
And
maybe
improper maintenance of roads are leading to accidents. Like the roads have such a big dug holes, and the material used to construct the roads are very of cheap quality,
absolutely,
which is
not only roads, our flyovers are falling on our
flyovers.
heads
So,
all the time, bridges and flyovers. Yeah, that's
mm.
a failure in civil engineering. That can happen. It can happen also with aviation. All right, flights, with airplanes, there are also some.
Yes, ma'am,
We'll be
aircrafts.
talking about some examples there. So I just gave you a brief, maybe we can add up one point here on, let's say, one bullet point on, what should I say, insufficient, I add is sufficient research and testing of design or product, whatever product, project, no, we can't say project. So I've just added one point here. Okay, you can check up on this also. And testing of design leading to malfunctioning. So this is also there. If you can come up with any more points, please point them out. Okay.
Okay.
Now, yeah. So now we will move on to the types of accidents. Okay, what kind of accidents can occur because of what reason? We'll go through them with small examples like we did in what is that, risks. Okay, there are many ways in which accidents can be categorized, all right, and then studied. One method is to group accidents into three types. What are the three types? Three major types: procedural accidents, all right. The next one, I skipped that slide. The next one is, we will go on. One is procedural, the next one is engineered accidents, and the third is systemic accidents. All right. The first one is um, procedural accident. The next one is engineered accidents, and the last one is systemic accidents. Is that clear? So we will finish with these here. The next few topics are just on risk assessment, which I already talked about in the beginning of the class. So let's go on to the first one. So there are three categories. The first category is procedural accidents. All right. Now, what do I mean by procedural accidents? This relates to the process in which a particular creation is used, and it is one of the most common methods, common types of accidents that occur. A thing can malfunction because the method in which it works is not appropriate. The product that you are using does not work properly because of some kind of malfunctioning. The procedure in which it works is not appropriate. So an accident can arise. There is a risk involved. Like I talked about the cell phone, these Chinese cell phones. Okay, if that is the case, I'm not saying it has happened. I'm just citing a case where it could have happened. It can happen with any other also. All right. So the process in which that particular product works or the creation works can have a defect. All right, in its working, and that kind of accident is called a procedural accident. And most accidents in engineering are procedural accidents. All right. Let's take up an example of procedural accidents. Just now we talked. I just told you about the aviation industry. In the airline or aviation industry, procedural accidents are frequently labeled as pilot error. The latest one is the one that happened in the army. We still don't know. Yesterday, I was trying to find out the cause for the helicopter accident. They have got the black box. They're still working on the details. They are saying that the accident probably occurred because of foggy weather, and the pilot not being able to assess the distance from the ground because of the foggy weather. So, and apparently the army uses their own traffic control information. They don't depend upon the ATC, the normal, the airport traffic control. They don't take up details from there. They use the traffic control details given by the army, who has their own way of monitoring things. All right. So it could either be because of the fog. That is what they're now saying. Initially, this is what one of the articles said, that the helicopter accident in Kunur happened because of foggy weather. All right. But my question is, they were still 7 minutes away from their destination. So why would the pilot want to land before that 7 minutes is the question. Was he flying so low, or at some point where the fog was so much that he couldn't see anything in front of him? And why didn't he the army personnel and the ATC also said that they did not send some kind of, they use their own code, where they inform the traffic control, air traffic control. What kind of information is that he used? I forgot the word. There is a term for that. They did not send what was that? Black something, I think he said. That kind of a message also did not come from the pilot. The last message received from the pilot of the helicopter said that they are, where they are, or a positive kind of information came. So why suddenly why did this aircraft suddenly collapse? What happened? Is it because of something that happened in the machinery? That also they are negating, because they said that it was thoroughly checked before the flight left, the helicopter took off, because it was carrying VIPs. It was carrying VIPs, and it was a flight that was scheduled to go and come back in 10 minutes. So it is not that the helicopter was not checked. Now the question is, was it thoroughly checked? That is the question. Who checked it and what happened? Now there is only one survivor. If he survives, I don't know what the latest news, if he's still surviving, some kind of information can be got from him. But what possibly could have caused this? It could be a procedural defect. It's a procedural accident. So all accidents with airplanes or in the airline industry are because of procedural, because of the the procedure that is involved in flying. Okay, someone takes bad decisions or makes a bad choice, and the result is an accident. All right. So these pilot errors are accidents. In airlines, it is because it is labeled as pilot error. All right. Now these accidents or procedural accidents are caused by the misreading of an important gauge. Uh, flying when the weather should have dictated otherwise. You see weather, or failure to follow regulations and procedures. Okay. In the airline industry, this type of error is not restricted to the pilot alone. It can also be committed by air traffic controllers and maintenance personnel. Right? The process or the procedure can get sabotaged or hampered, not only because of pilot error, but also because of the weather, the misreading of important information that is sent, or failure to follow regulations and procedures, and also because of inappropriate or insufficient what should I say, messages or information given by the air traffic controllers and the maintenance personnel. Is that clear? People who do the maintenance. That's about procedural accidents. Is it clear? Can I move on to the next one? You
Yes,
can
ma'am.
try to find out your own examples of procedural accidents also. Please don't reproduce the examples that I'm giving. There are plenty of examples of procedural accidents or engineered accidents. If you understand the term, then you should be able to find out and explain what you mean by procedural accidents with your own examples that you have found out. So please don't just reproduce what I have given you. Okay. The second kind is engineered accidents. These are caused by flaws in design. That is what we have been seeing in my last few slides, in my talk today from the beginning. These are failures of material devices that do not perform as expected, or devices that do not perform well under all circumstances. Major accidents have happened because of engineering flaws, because of design flaws in the design in engineering a product. All right. So the material used could be substandard, or the materials. If you could. Again, here you have rockets, you have what is that, spaceships that are sent up, uh, a number of um, accidents have occurred. See, that which one was that, where you had this Kalpana Chawla who expired, those people who went up to space. Theirs is a perfect example of an engineered accident. Some device probably did not perform properly, or did not function at that particular time. All right. The circumstances were such that the the thing in which they were traveling was finally forced to explode. They had no other option to come back. They had no option to come back to Earth. All right. So maybe some flaw in the design, some what should I, flaw meaning mistake in the design or the devices that were used. If you go up, you can, again, for this you can check up accidents, engineered accidents. You have plenty of examples on the net. Try to pick up any one of them and see what caused that accident to happen. What engineering defect was it, in the design or the material that was used? All right. You can check out that, and as a result of this you have something related to it called whistleblowing. When something like this happened, there is one example that you will see, because of engineered accidents and whistleblowing, people try to suppress. Okay. And the problem, even now, I don't know if this helicopter accident, what is happening, was it an engineered accident, or was it a procedural accident? We don't know. All right. So we need to find out. It could be because of some machinery, some device that did not function or perform as it was supposed to perform, and therefore uh, maybe misguided the pilot. All right. So it could happen. So, for example, micro cracks sometimes develop in turbine blades in aircraft engines. When these cracks become severe enough, the blade can fail and break apart. Sometimes this has resulted in penetration of the cabin by metal fragments causing injury to passengers. Alright? Engineered failure should be anticipated, can be expected. Anticipated meaning should be expected in the design stage itself. They should be expected. These kind of failures should be expected or observed or noted in the designing stage itself and should be caught and corrected during testing. They should not be left. If it skips your knowledge, then it could end up in an engineered accident. All right. So this correction must be done right away in the beginning during the design stage itself, because engineered accidents happen mainly because of flaws in design. And engineered accidents can be understood and reduced as more knowledge is gained through testing and actual experience in the field, which means that the theoretical knowledge and the practical knowledge, the bridge between the two or the gap between the two must be bridged, all right, to prevent engineered accidents. Theoretically, it's one thing, and practically, it's another thing. So, you must make sure that what you have learned in theory has been appropriately represented in the practical form, and there is no gap between the two. Otherwise, it can end up in an accident. If you're being very theoretical and not bothered about the practical side, an engineered accident can occur. Okay. And the last type of systematic accident that we're talking about is, one second. I missed one slide there. I'll go back to it later. Systemic accidents, this is a third type. These are harder to understand and even more hard to control. They are characteristic of very complex technologies and the complex organizations that are required to operate them. A perfect example of this again is the airline industry. All right. It can happen. Is somebody trying to join the class? I can hear. Okay, no. Not only in the airline industry, systemic accidents, systemic coming from the word system, all right? It can happen in the airline industry because it's a chain of systems that are involved in the airline industry. It can also happen in the medical field, all right? Where different kinds of machinery are, linked together, maybe during a major surgery, and if any one of them malfunctions or in the system there is some kind of a flaw, then it can end up in a big disaster. If one component one component, if I say, in the airline industry fails to function appropriately, it can cause a chain of reactions and a major accident find. Different causes, as we said before, there'll be a number of causes. The small, if one of them malfunctions or does not function appropriately, it will affect another, then that will affect another, and there will be a chain of things that will be affected, causing in a major disaster. All right. Modern aircrafts are complicated systems. In the airline industry, I'm giving you this example. Running them properly requires the work of many individuals, including baggage handlers, mechanics, flight attendants, pilots, government regulators, and inspectors and air traffic controllers. All these people are involved. It's a cycle. All right. It's a cyclic chain. It's a cycle. And if any one of them, goes out of the system, the entire system will be affected. And that is when a systemic accident can occur. If the air traffic controller does not give appropriate and timely information or message to the pilot, it can affect the landing of a plane, and it can cause a congestion in the airport. All right, the flight may not be able to land, and there will be lagging. And what will happen is when the airplane finally lands, there will be a rush of passengers. Okay, checking problems will be there. Baggage handlers will have a problem. The mechanics will be under pressure to check, if the flight has to go back. 2-3 flights landing at the same time, when they should have landed one after the other, and the mechanics would have had enough time to check all the flights thoroughly. That does not happen. So the technicians will run short of time, and they might do a superficial checkup, and that can end up in another airline mishap. Okay, flight attendants will also be affected. All right. So the pilots, government regulators, everything, the entire chain will get disturbed. All right. Just because of one air traffic controller, or just because the air traffic controllers have messed up, everything is the entire chain in the system will get affected. At many stages in the operation of the airline, there are chances for mistakes to occur, some with serious consequences, all right, or some are minor and can be ignored. Often, a single minor mistake is not very significant, but a series of minor mistakes can lead up to a major disaster. A small mistake by an air traffic controller can get the entire system shaken up, all right, and can affect till the flight lands and passengers leave the airport, affecting even the baggage handlers, the bringing of luggage from the flights. All right, entire thing will get disturbed. Other salient examples of systemic accidents are the modern military system and nuclear power plants. Okay, these also function under a chain of systems, and if one malfunctions, then this is entire system is at risk. Okay, nuclear power plants can get affected. Nuclear radiations can happen, causing loss of lives. All right, if there is a fire or there is an accidental release of you know all these things, the radiations that happen in nuclear power plants, there'll be total chaos. If you take up example of this Bhopal gas tragedy, that's also one case. I've just mentioned it here. See, the Bhopal gas tragedy is also in India is a classic example of systemic accident. You can look up the Bhopal gas tragedy in India. How many people died because of one small mistake in the the what is that, the oil company there. So there are a lot of documented accidents with evidence of systemic accidents happening because of one small flaw. All right, so this is about systemic accidents, and these are the three major types that we talk when we talk about the types of accidents. So with that, we are almost done. My next slide is on risk assessment. Risk assessment is, the last step after the testing and everything is over, and when I was talking about risk analysis, I talked to you about this. Uh, when you come up with the final solutions of how you will tackle all the risk and the safety, especially the risk, that is called risk assessment. Risk assessment is nothing but identifying hazards and risk factors that have the potential or the ability to cause harm. All right, that is risk assessment, assessing or trying to evaluate what can cause damage, danger, or an accident. What are the factors in any uh, engineering product that has been designed? Okay, so this is a fag end of the entire process. Starts with the risk analysis and ends with risk assessment. Okay, so what does risk assessment do? It determines the appropriate ways to eliminate or delete the hazard or control the risk when the hazard cannot be eliminated. Risk assessment is, in other words, a method by which you will try to minimize risk as far as possible. Is that clear? The risk of any kind of danger that is involved in the creation and usage of a product. That is about risk assessment. And when you take control after you find the solutions, all plus, and you study the pros and cons, that is called risk control. Okay, you take control of that. Now, what are the 5 steps involved in risk assessment? You have to identify the hazards. That's what I said. No, when you were talking risk analysis, you will have to identify the cause. What are the pros and cons of the product that you've created? Identify the hazard. What can cause harm? This will focus more on the harm factor rather than the need factor, which is there in the entire risk analysis process. Risk analysis starts with the need for creating a product. What is the need or requirement for this product, and how you can fulfill the need. And in the process, identify the problems or the hazards involved in creating that product and coming out with a solution. and minimizing the risks. That is what risk analysis is about. And risk assessment is the last step in risk analysis. So what you will do here is identify the hazards, identify who may be harmed and how if there is an accident because of risk, a lurking risk or danger in the product that has been created. You assess the risks and take action, which means you're doing risk control. You try to minimize the risks, okay, as far as possible. How you do it is what is called taking action. Make a record of the findings of what problems were there, how much you have controlled it, and what is the final outcome. What is your final finding? Where do things stand now? How much percentage of the risk could you minimize? You have to record. What was the percentage before? What is it now? All right. Review the risk assessment. Were you able to minimize the risk, or is it more, or is it the same as before? You have to review it. Only after review, you can think about more research on how things can be taken forward, whether the project is fit to be implemented, what more has to be done in the project, what more action has to be taken, what more research has to be done on the new product. That is what reviewing the risk assessment is all about. Okay. And once, this is the last thing that we talk about, something called accountability and liability. Whenever there is an accident, it means that the safety has been somehow compromised and the risk factor has become primary. All right. So somebody has to take the blame for that accident happening. That is what we mean by accountability. Somebody has to be liable for the problem that has occurred, the accident that has occurred. All right. So accountability means the capacity to understand and act on moral reasons. Now, you take the blame for what has happened, whether good or bad, on moral grounds. This thing happened because I made a mistake, or we made a mistake. We did not test the problem. We did not do sufficient research. We did not do sufficient testing. And before that, we let it out into the market. There was this potential risk, this risk was there, but we did not bother to work on it, thinking that it might not cause much danger, but it has happened. So we are accountable for the accident. We are liable for the loss of life. We are liable, meaning responsible. Okay. Accountability is taking the blame, maybe, and liability is taking the responsibility of what is. We try to understand the situation and accordingly try to take responsibility of what has happened. If it is fair enough, you take the responsibility. If not, you will have to try to justify on moral grounds that whatever has happened because it is not our fault entirely. There are other reasons what I say. Maybe the user's fault is also there. We also are liable. We are also accountable for the problem. So there's a kind of a balance of taking blames. And accountability and liability are related to accidents because it is here, in this case, in the case of accountability and liability, you are expressing your willingness to submit your actions to moral scrutiny. Okay, moral scrutiny meaning some kind of judgment. Okay, and you are trying to be responsible to that judgment or assessment made by others on whether you are actually to blame for the accident. So that is why these are related to accidents and risks. So it is being liability and accountability is being you are responsible or you are liable to justify. You are in a position to justify or give reasonable excuses, valid excuses. All right, the decision on why you probably worked on particular design, you did this thing and you did not do that. All right, why you took this particular action or you have opted for this kind of method. You saw that there was more safety involved here, that's why you did it. So you justify that. So accountability and liability involves justifying your actions and means, your methods for doing something, to come out clear. All right, to take responsibility of the outcome or the result of an accident which was unexpected. Sometimes is unexpected. All right, whenever required by stakeholders or by the law. If you are penalized by the law, then you must take a firm stand and be able to justify why you are not in the wrong. And even if you're in the wrong, why are you able to accept it? If you're in the wrong, then you'll have to pay a compensation, all right, and you will have to take the blame. And if you're not in the wrong, you will have to justify and say that this is entirely not my fault. You see, these are the papers that we have. These are the steps in which we researched, analyzed, did the risk assessment and all that, and we were clean. There was a minor percentage of risk which came into existence because probably the user did not use it properly, or because it was an engineer accident, some problem there, or it was because of a malfunction of a machine or a part that could have happened. It is not deliberate. We did not do it deliberately. We did not have that in mind. So being able to take the blame and justify is what accountability and liability is in the case of an accident. All right. So with that, I am done with Unit 4. Do you have any questions? Did I rush through? Did I have too many?
No, ma'am. It's
Was I able to get the point through to you?
yes, ma'am.
Okay. No questions. Nobody. I will stop sharing this slide.
Ma'am,
Yes.
ma'am, I had not done the first assignment because I have joined late.
Okay.
So when I should submit that?
Okay, it will be nice if you can talk to your friends and try to do it, because you see, ultimately the entire syllabus will be there for your exam. No. So what will happen is, if you don't do it, you will not be able to add that kind of information when that question comes. It's not a very big assignment. What I had told them was, every company, every business organization has its own vision and mission. All right. Even your Calcutta University, when you enter your college, I don't know if you've started entering your college campus at Rajavacha Science College. When you climb the steps and go, you will see there's a board with vision, mission.
Yes, ma'am.
Right? Have you noticed
Yes,
that?
ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
So every organization must have a vision and mission. Without that vision and mission, you will be like what should I say, cows and goats grazing anywhere and everywhere on the streets. So you must have a vision. All right. The vision will help you to reach your target. So every business organization who wants to survive in the market and have a goodwill will want to have their own vision and mission. So I asked you all to identify any 3 companies and find out what their vision and mission is. If you surf the net, you will find out what the vision and mission is. The second part of the assignment was, every company has a vision and mission, and they try to fulfill it sometimes through something called CSR activities. CSR meaning corporate social responsibility. Corporate referring to the business world. Corporate is business. Every business organization has a responsibility towards society. Society meaning people like us. We are the consumers of products that every business organization creates. And every business organization understands that they have to give back something to society. Society gives to them in terms of money. We buy their products, all right? And that is how the business organization survives in the market. If not for us, they would have not survived. So they think that if people in society are helping us survive in the market, then we have a responsibility towards society. We must give back something to society as a business organization. So that responsibility that they have is called the corporate social responsibility. Corporate has a responsibility towards society. That's why it's called CSR. Now, how do they fulfill this? How do they give back to society? By conducting, programs, sometimes blood donation camps. They conduct programs, and then they sell tickets, they get money, and that money is either given to cancer hospitals for cancer patients, or to blind schools, or the blood that is collected in a blood donation camp is given for thalassemia patients. So many things. The SBI sometimes, or different banks, they will conduct educational programs, quiz and all that, and they will give prizes, and they will give the winners either cash in price, or they will buy them books or stationery or whatever a student might need to do in school, or to help him in his education. Sometimes they give loans with very minimal interest. So that's the corporate social responsibility of an organization like SBI. I'm not saying it is a once upon a time, sometime SBI did it. All right. These activities by these organizations are sometimes, I used to find them in the, at least in the Telegraph, in the happenings page. There are small columns, small articles where they say, this organization conducted a blood donation camp, or they had, what should I say, some educational program where some VIPs were called, or some, first celebrities were called. Prizes were given away to the highest, what a madhyamik scorer, or a ucha madhyamik high school scorer. So to encourage education in children. Then you have, what is that? Which company is that? I'm not getting the name. Is it ITC? Who donates 1 rupee every time you buy a product? 1 rupee that comes is gone for the education of the girl child. They have notebook. What is that? Notebooks also? No classic classmate notebooks. So every time you buy them, 1 rupee goes towards the education of the girl child. All right, or the upliftment of a girl child. Now, what I'm trying to say is, vision and mission of an organization is related to its CSR activities. Both of them are interrelated. All right, they fulfill their vision and mission through CSR activities also. So that is why the second part of my assignment was, one second. The second part of the assignment was, try to find out what are the CSR activities of these companies. All right, because the two of them, vision and mission, go hand in hand with the CSR activities. So try to find out some. It may be the CSR activity of the same company for whom you found the vision mission, or it can be somebody else. You can,
Okay,
the
ma'am.
two can be different companies. Yeah. Yeah, or just write CSR and send it in the subject line.
Okay, ma'am.
Okay, send
Thank you.
subject line. It need not be the same companies for whom you've done vision mission. Because, just give me 1 minute, 1 minute. Hello. Okay. So it can be that, because it doesn't mean that, let's say, I'm talking of Infosys, I find out the vision and mission of Infosys, but maybe in recent times, Infosys has not done any CSR activity. So it'll be very difficult. So for CSR activity, you can identify anybody else. And if you can, the CSR activity is actually mentioned even in the vision and mission. So if you can find some other company, find out what is their CSR activity in recent times, or maybe before, maybe recently because of COVID it was not possible. Infosys also might be doing some CSR activities, because you have Sudha Murthy, who is involved with Infosys, and she does a lot of social activity through Infosys. So you can, maybe you can link it, or otherwise take any other three companies or business organizations, and try to find out what their CSR activities is. Maybe not in recent times, maybe before. It is just to know what they're doing, and you get the concept clear. It's small assignments. So I gave you, that was the first assignment that I gave you.
Okay, ma'am.
Ma'am, company like TCS, they have a pretty clear, they just mentioning their vision and mission in their website. If you check
Yes.
that, uh, yes, ma'am.
Yeah, most of them, most of these established, well established companies have it on their website. That's why I said it's not a very tough assignment that I gave you. And what I'm saying is, all of you don't do the same things. Okay, suppose the question comes in your exam, all of you will have only TCS, Infosys, and TCS and Wipro, all that. Try to find out other companies, international or whatever it is, and bring in variety. If an external sees your paper, they must know that yes, you understood the concept because you are giving various examples. So your examples will be your own. You will be able to use it in your answer paper. Don't copy paste from another person because you didn't do the assignment, or you didn't feel like doing it and you just borrowed it and put it there. Don't do that. I haven't given you a
Ma'am,
deadline, but maybe by next week you should be able to finish it so that I can even add your marks and attendance details and send it to the office. Will you be able to do it by next week?
yes, ma'am, definitely.
Yeah?
Yes, ma'am. We'll
Okay.
try.
Somebody else had a question. Were you trying to say something? Anybody had a question?
Ma'am, there is a pretty giant brand like YouTube, but they don't have any vision mission mentioned in their just go through some that what they have done in the past and they are evolving. Like when YouTube was launched, their mission was something else. Then now is something else. It's evolving with time.
Okay, they're evolving with time, but don't you think they should have a vision and mission? Which means that somewhere something is missing, and it might give you the impression that they're trying to con people.
Ma'am, they should have.
Yeah, they should ideally have. They are doing so well, they're making a lot of money. So that's very unethical of them not to be, disclosing their vision and mission. Very unfair. They should be disclosing it because there are so many people making money out of YouTube videos. So what is the mission of YouTube? Why are they existent? What do they want to do? What kind of services are they providing? We need to know, isn't it? Rup Kumar Biswas says,
Um,
yeah,
that I
yeah.
have mentioned.
Pardon me?
Ma'am, in my assignment, I am said that.
In your assignment, you have?
Ma'am, in my assignment, ma'am, I have included that those points like YouTube is
Yes,
helping
absolutely.
creators to
That's
make
that's a
money.
good point that you brought out. That is it appropriate for such an organization not to have? It's a deficiency that they have, and why don't they have it? Okay, Rup Kumar Biswas, somewhere you said I shared a jam file with the meeting. What is it about?
Sorry, ma'am, this is by mistake.
By mistake? Okay. I thought you were trying to send something here, so I wanted to verify. If I close shut down, if I leave the meeting, it will disappear. That's why I wanted to know what it was. Any other questions? Can we wind up?
Ma'am, for those who have submitted both the assignments 1 and 2 combinedly, I mean, I've written both the CSR activity and the mission and vision, so I don't need to resend it, isn't it?
No need. Some of them have forgotten to send the CSR. It skipped their mind, so they will send it that alone separately to me.
Okay, thank you.
And all of you send it to that same email ID where you send your answer papers.
Okay, ma'am.
Okay? Don't send
Yeah,
it
and
to my
ma'am,
personal
please,
email ID. I will lose it.
and you can confirm by via
Yes,
list the
I
silver,
will
yeah.
confirm. Some of you have already sent. Like once it's done, I will give you time. Maybe this is today is Tuesday. No, by next Monday, if you put it in on Tuesday, I'll confirm with all of you.
Okay, ma'am.
Okay, thank you.
That will give you time, and then I can personally confirm it when we are doing the class. Okay. Okay then. Thank you for being
Thank you,
there. Let's break off leave for today.